In this lesson, we want to talk about combining graphing transformations. So up to this point, we have individually studied the graphing transformations such as a vertical stretch or compression, a horizontal stretch or compression, a vertical shift, a horizontal shift, something like a vertical reflection, which is a reflection across the x-axis, and then a horizontal reflection, which is a reflection across the y-axis. But what happens when you have multiple transformations? What is the correct order? How exactly does that work? All right, so I'm just going to start off with the easiest scenario, which is the order of vertical transformations. So if I look at something like f of x equals the square root of x, and then I look at something like g of x equals 3 times the square root of x minus 5, the first thing I would do is write g of x in terms of f of x. You see you have this square root of x here and square root of x here. So I'm just going to say that g of x is equal to 3 times, again, for this right here, it would just be f of x, because f of x is equal to the square root of x, what I have right there. And then you have this minus 5. So individually, we know how this works. If I mark this part out right here, what is 3 times f of x? Well, that's giving me a vertical stretch by a factor of 3. And then if I was to mark out this right here, what is f of x minus 5? Well, that's giving me a shift down by 5 units. But what do we do when we have both of them? What's the correct order? Well, it turns out it's just going to follow the order of operations. So you would multiply first, and then you would subtract. So in other words, you would want to do this vertical stretch by a factor of 3 first, and then you would want to do this one second, which is the shift down by 5 units. So that would be the correct order here. If you want to see this in action, what you can do, let me get rid of this. You can just plug in. So let me just get rid of this as well. And you could just take a few ordered pairs. I have a graph for you, which I'm going to go down to in a moment, and I have a link for you on Desmos if you want to follow that. Let me just show you that real quick. So this is what we're going to be working with, and we're going to go through these points. So let's just start with 0, 0 and 0, -5, and I'll show you where that's coming from. So let's say you have f of 0. This is equal to the square root of 0, which is equal to 0. So we know f of 0 is 0. Well, for that same x value of 0, what is the y value going to be? A lot of you know it's going to be -5. You can eyeball that. But again, g of 0 would be equal to, now you have 3 times 0 and then minus 5. Well, all I had to do was replace this right here with the y value that I know that would be produced from that same x value here. So 3 times 0 would be 0, and then minus 5 would be -5. So this becomes 0 minus 5. This is -5. Again, you're just following the order of operations. 3 times whatever the y value was, in this case it was 0, and then minus 5. So you do them in the same order as when you're doing the order of operations. So this is -5. Again, just to show you this on the graph, here is your 0, 0. Here is your 0, -5. So we have 1, 1 and 1, -2. So let me get rid of this and just put in a 1 here. And basically, if you put in a 1, you would have the square root of 1, which is 1. So if you did g of 1, again, for that same x value, you don't actually have to plug in because you know the result of this part right here is going to match this part right here. If I plug in a 1, I get a 1. So I can just start with that y value of 1 and say, okay, well, 3 times 1 minus 5. That's what I'm going to end up with if I plug in there. So I would just follow the order of operations. Multiply by 3 first. That's going to give me 3, and then subtract away 5 second. So 3 minus 5, that's going to be -2. So that's how you get that point, 1, -2. Again, coming back, this is your 1, 1. That's going to go to 1, -2. Let's do this one and this one. So 4, 2, that's going to go to 4, 1. So let's do f of 4, and we'll do g of 4. So for f of 4, again, it's just the square root of 4, which is going to be 2. Let's put a 2 right there. And then for g of 4, again, I don't need to plug in a 4 there because I know that the result of that is going to be 2. So I can just take this y value that I know and just put it right there. So it would be 3 times 2 and then minus 5. Again, just following the order of operations, 3 times 2 is 6, and then 6 minus 5, that's going to be +1. So you would get 4, 1. So this one is 4, 2, it goes to 4, 1, again, so on and so forth. A lot of times you'll see in the textbook that they'll write things where they say, well, for this x, y, that's going to be on your graph of f of x equals the square root of x. What's going to happen is, as you go to this g of x equals 3 times the square root of x minus 5, the x value stays the same, but the y value, again, first you're multiplying by 3, so you can say 3 times whatever y is, and then you're going to subtract away 5. So that's going from this one to this one. Again, if you want to take, let's say, this one right here, and you would have the same x value of 9, so you see that here and here, and all you'd have to do is take that y value of 3 and plug it in there. 3 times 3 is 9, 9 minus 5 is 4, so that's how you get that 9, 4. So this is a good way to do it if you want to check your work. All right, so just to go through the order of vertical transformations, let's say you had something like g of x is equal to a times f of x, and then plus some k. Well, your a here, again, that's going to be your vertical stretch or compression, along with any reflection across the x-axis if that's negative. So I have the order listed to where a is done first. So basically you could perform any vertical stretch or compression if the absolute value of a is greater than 1, we have a vertical stretch. If the absolute value of a is greater than 0 and less than 1, we have a vertical compression. Again, some people use the term shrink. Then I have for number 2, perform any reflection across the x-axis. So that's your vertical reflection. So this is when a is less than 0. You can switch 1 and 2. It does not matter. As long as you do it before 3, you're okay. Typically, when they list the procedure in a book, these will be different depending on the resource, or they might even put them together and say do any vertical stretch or compression along with any reflection. So these you could just consider as one step or just switch the order, whatever you want to do there. It's just important that the third thing or the last thing you do if you're doing vertical transformations is that you perform any vertical shift. That would be last, again, because of the order of operations. So up k units if k is greater than 0, so if this is positive, and down by the absolute value of k units if k is less than 0, so if this is negative. All right, let's look at an easy example here. So we have f of x equals the cube root of x, and then g of x equals negative 1/2 times the cube root of x minus 3. So one thing that might be helpful for you, you don't have to do it all the time, especially once you get good at this, but you want to write things in terms of f of x. So g of x is equal to, you have this negative 1/2, and then times, again, this is f of x right here, so the cube root of x, and you have that right there. So I'm just going to say times f of x. And then you have this minus 3. So we can slide down. So we have enough room. We don't need that on the screen anymore. And basically, if you want, you could just go left to right. So that's what I typically do. Again, this one right here and this one right here, you can do that in any order. Just make sure you're doing the multiplication before you do the subtraction. So in other words, I could say that this right here is number 1, this one right here is number 2, and this one right here would be number 3. Again, it would not be incorrect if you said that this was 1 and this was 2, but I like to list it this way because you're just working left to right. It's easy to remember. So that negative that's out in front, that's giving me a vertical reflection or a reflection across the x-axis. So let's say reflected across the x-axis. Let me fix that. The second thing, you have this 1/2 here that's doing a multiplication by f of x. Again, that's giving me a vertical compression by a factor of 2. Let me put vertical compression by a factor of 2. Now, let me stop here. Again, a lot of books, a lot of teachers have different terminology for this. You might see in a book where they say there's a vertical shrink by a factor of 1/2. So if that's what you want to use, it's equally correct. Whatever terminology fits, the way that you like to study, it's okay. You're just taking the y coordinate and you're either, you could say multiplying it by negative 1/2 or you're dividing it by negative 2. So that's where these two steps are coming from. So the third thing here, we have this minus 3, and that's just going to shift me down by 3 units. So let's say we're going to shift down by 3 units. And that's basically it. You're reflecting across the x-axis. You have a vertical compression by a factor of 2, and then you're going to shift down by 3 units. So if you had some x comma y, that's on the graph of your f of x equals the cube root of x, well, when you get to g of x equals negative 1/2 times the cube root of x minus 3, what is going to happen to the y coordinate? So the x would be the same here. For the y coordinate, again, you're just going to multiply by negative 1/2. You could say that's negative y over 2, and then you're going to subtract away 3. So that's how you can check it. You can just go to the graph. Again, I've got a link for you on Desmos if you want to follow along with me here. And so you could just pick something like, let's say this 0, 0. So if you had 0, 0, what is that going to go to? Well, the x is the same, still going to be 0. The y value is, you plug it in right there. So the negative of 0 is still 0. 0 divided by 2 is 0. Then you subtract away 3, you get negative 3. So this 0, 0, that's going to go to 0, negative 3. Let's do another one. So you have this 8, 2. So 8, 2. Where is that going to go to? Again, the x value stays the same. The y value of 2, you plug that in there. So you have negative 2 divided by 2, that's negative 1. And then negative 1 minus 3, that's negative 4. So you see down here, you have 8, negative 4. You could do this one as well. Turns out that once you go through it, you're still going to have negative 8, negative 2. So you have negative 8, negative 2. That's going to go to what? So the x value is still negative 8. And then you plug in a negative 2 here. So this one's tricky. Let me do it. So you have the negative of, you plug in for y. This is over 2, and then minus 3. You have to be very careful when there's a negative right there. A lot of people will make a mistake, and not plug in another negative. They'll just say that it's -2 because the negative's already there. But what you want is the negative of -2. So be very, very careful. There's a negative out in front there. So the negative of -2, that's +2. So this becomes +2 over 2 minus 3. And this is 1 minus 3, which ends up being -2. That's why you get that -8 comma -2. So that is going to be no change in that particular case. All right, now let's cover the more challenging scenario, which is the order of horizontal transformations. We're going to see that this follows the reverse of the order of operations. But where does that come from? Well, let's start off with f of x equals the square root of x, and then g of x equals the square root of -1/2 x minus 1. The procedure that I'm going to give you might be different in your textbook or your resource, and this is based on whether you factor or you don't factor. So if you don't factor like I'm about to do, you need to go with a different order. You would just check your resource for that. So first off, let me write this g of x in terms of f of x, and I'm going to factor. So I'm going to say that this is f of this right here is just being plugged in for x right there. That's all it is. So I'm going to say that I have -1/2, and again, I'm going to factor that out. So I'm going to put some parentheses right here. So we know that this would be x. A lot of people get confused about what goes here. Again, just think about how to undo stuff. So I'm going to end up multiplying by -1/2. So how do I undo that? Well, I would want to multiply by -2. So take this -1, multiply by -2, you're going to get +2. We're going to close that down and then close this down. Now, why did I take the time to do that? Well, you're going to see in a moment when I get to function composition, this is going to allow me to say that this is going to go this one first. So I'm going to undo that. And how do I undo multiplication by -1/2? I'd want to multiply by -2. So the negative part is giving me a horizontal reflection. So that's a reflection across the y-axis. And then the 2 part, that's giving me a horizontal stretch by a factor of 2. Again, I know it's counterintuitive because you're seeing the -1/2, but again, you have to undo that. So you multiply by -2. Then this would actually be second. So we have +2 on the inside. We're going to undo that by subtracting 2 away. And so this is going to shift me 2 units to the left. Let me show you this with function composition. Okay, so for the function composition approach, let's say we have, again, f of x equals the square root of x. We're going to have this middle step here. So we're going to have this h of x equals f of -1/2 x. So if I was to write h of x right here, so h of x is equal to, well, all it is I'm taking this right here and plugging it in for x right there. So this would be the square root of -1/2 x. So that's all it is. Let me slide down. And basically we know that if we see h of x equals the square root of -1/2 x, again, comparing that to f of x, well, I have a horizontal stretch by a factor of 2, and I have a reflection across the y-axis. So I want a horizontal reflection there. So those two things would be done. We've talked about that previously. Well, now, if I look at g of x being equal to, I have this h of x plus 2. So that just means I'm going to plug in the quantity x plus 2 right there. So I need some parentheses. So I'm going to say this is the square root of -1/2 and then times the quantity x plus 2. And what is that going to do now? It's going to shift me to the left by 2 units. Again, I have to undo this +2 here. Everything on the inside is the reverse. You have to undo things. So what's going to end up happening is when we look at this compared to f of x, again, we saw that we did this one first and this one second. So I had a horizontal stretch by a factor of 2, a reflection across the y-axis. The last thing I did was a horizontal shift to the left by 2 units. All right, let me come back up here, and I'm just going to show you this using a tedious method of just plug and chug. But I hope it'll make sense for you because a lot of times when you first see this, it's very confusing because you're undoing things, you're going in reverse order. And a lot of times it's just not so straightforward like it is with vertical transformations. But if you plug things in and just keep going back and forth, it will make sense. So if I do something like, let's say f of 4. So we know f of x equals the square root of x. I know it's cut off, but this would just be the square root of 4, which equals 2. You see this is the graph right here. This is your f of x equals the square root of x. You have this point, which is 4, 2. So we know this graph. This is going to end up going over here to -10, 2. So let me show you that real quick. And first, I'm just going to plug in. Let me put a little border here. So I'm going to say, what is g of -10? Well, we're going to find that it's 2. So we're going to say that this would be the square root of, you have your -1/2. Again, this is in factored form, times the quantity, -10 plus 2. Let's close that down. So this would be equal to, what do you do first here? Well, you have parentheses, so you're going to do -10 plus 2 first. That's going to give you -8. So now you would have the square root of -1/2 times this -8. And then when you do that, you're going to have the square root of -1/2 times -8. Well, that's +4. So at this point, this matches this. So once I do this final step, I'm going to say this is 2. The issue is that I'm used to working with f of x equals the square root of x. I know there's a point 4 comma 2. I'm not used to working with g of x equals the square root of negative 1/2 times the quantity x plus 2. So I don't know about this point negative 10 comma 2. So what I would want to do is take that known x value of 4 and reverse the steps here so that I can get to negative 10. That way I know there's negative 10 comma 2 on the graph. In other words, if I reverse this, let me put another border here. So let's say we're going to go in reverse. So the first thing is to undo the multiplication by negative 1/2. To do that, we multiply by negative 2. So we're going to multiply by negative 2. The second thing is we want to undo this addition of 2. So that means we want to subtract away 2. So what does that look like? Again, if I start with 4, let me slide down here a little bit more. Well, that would be 4 times negative 2 and then minus 2. Well, 4 times negative 2 is negative 8. And then negative 8 minus 2, that's going to be negative 10. Well, notice that gets me right there. Again, I had to start with what I knew. I know that point 4 comma 2 is on that graph of f of x equals the square root of x. Start with that x value that you know, and then go in reverse. So first multiply by negative 2. Again, that gives me the horizontal stretch by a factor of 2 and a reflection across the y-axis, and then subtract away 2. That's giving me a shift to the left by 2 units, and I'm going to end up with negative 10. So I know negative 10 comma 2 is on the graph right here. In other words, if you have some x comma y on this f of x equals the square root of x, when you go to g of x equals the square root of negative 1/2 x minus 1, well, you could really say that, again, the first thing I want to do is undo the multiplication by negative 1/2. So that's multiplying by negative 2. So you have negative 2 times whatever the x value is. And then next, I want to undo the addition of 2. So I want to subtract away 2. So it's just negative 2x minus 2, and then comma, the y value would not be changed. So if you took this x value of 1 here, well, if you went through the process, negative 2 times 1 minus 2, negative 2 times 1 is negative 2, and then minus 2, that gives me negative 4. Well, notice that over here, you have this x value of negative 4 that corresponds to that same y value of 1. And I'll let you do the other points on your own. Again, all we're doing is we're going in the reverse of the order of operations. Now, if you don't factor, you would have a different order of operations, and so you're going to get a different reverse order of the operations. So that's why if you're in your textbook and they don't factor, they'll tell you they want to do the horizontal shift first and then followed by the horizontal stretch or compression along with the reflection. Again, we're not going to do that here. We're always going to factor. All right, so just to put this together, let's say that we had g of x is equal to f of, let's say, bx minus h, something like that. Well, we would factor this first. So we would say g of x is equal to f of, pull out the b, inside you'd have x minus h over b, close all that down. And so looking at this, again, in factored form, if it's not in factored form, again, you're going to get a different order of operations. And so when you reverse the order of operations, it will be different. So if you're in a book and it says to do the horizontal shift first, it's because they did not factor. Okay, so I want to make that crystal clear. So the order given below is for the factored form only. So you're going to begin by factoring out the coefficient of x, which we did. Coefficient of x was b, we pulled it out. Then you're going to perform any horizontal stretch or compression. So if the absolute value of b is greater than 1, we have a horizontal compression. Again, some people say a shrink. Remember, you're trying to undo things. If the absolute value of b is greater than 0 and less than 1, we now have a horizontal stretch. Then you want to perform any reflection across the y-axis. Again, that's your horizontal reflection. So this is if b is less than 0. Again, this one right here and this one right here, you can do them together. You can switch the order. As long as, again, when it's in factored form, you do it before you do the horizontal shift, you are okay. So we're going to then perform any horizontal shift. So we're going to go right by h over b if h over b is positive. Again, this is minus some positive number. That means you're going to the right by h over b. It's left by the absolute value of h over b units if h over b is negative. Again, minus the negative would be plus a positive. So if this was plus some positive h over b, now you're going to the left by, I guess if we converted it to positive, you say h over b units. Again, if you keep it as negative to match this form, you'd say the absolute value of h over b units. Okay, let's look at an example. So we have f of x equals the absolute value of x, and then g of x equals the absolute value of 2x minus 4. So if you want, again, not necessary, you could write this as g of x is equal to f of, again, this gets plugged in there, and I'm going to factor. So 2 times the quantity x minus 2. Let's close all that down. So this right here is done first, and this is done second. Let me write that as this is 1, and this is 2. Because we're undoing things, so we're going in the reverse of the order of operations. If you can't remember this, again, just remember factor and then go in the reverse of the order of operations. You know what the order of operations, you work inside the parentheses first, followed by doing this multiplication. Well, now you're going reverse, so you need to undo this first and then undo this second. Everything must be undone. So how do we undo multiplication by 2? We divide by 2 or we multiply by half. So the first thing is we have a horizontal compression by a factor of 2. Again, a lot of people like to say that as a horizontal shrink by a factor of a half. Different terminology, same meaning. You're taking the x coordinate and dividing it by 2 or multiplying it by a half. The second thing is you have this minus 2. I need to undo that. So I want to add 2. That's going to shift me to the right by 2 units. So you could say shift right by 2 units. So that's all we're really going to do here. So for a given y value, let's say you have x comma y on the graph of that f of x equals the absolute value of x. When you get to g of x equals the absolute value of 2x minus 4, well, now we're going to take the x and we're going to divide by 2, or again, you could multiply by half, and then we're going to shift right by 2 units. So we're going to add 2. Again, the y value would not be changed. Let me go ahead and grab this. And again, I have a link for you if you want to check this out on your own. So you have something like negative 6 comma 6. That's on the graph of f of x equals the absolute value of x. Again, the y value of 6 is going to be the same. The x value is now going to be found by saying, well, you take that x value of negative 6, you divide by 2, and then you add 2. Well, this becomes negative 6 over 2. That's negative 3. So negative 3, and then plus 2, that gives me negative 1. So that's how you get this x value of negative 1 paired up with this y value of 6. Let's do the other ones. So this one is 0, 0. This is going to go to 2, 0. That's pretty easy. If you plug in a 0 right here, you end up with 2. So it would just be 2, 0. And then this one is going to be 6, 6 going to 5, 6. So let's go 6 over 2 and then plus 2. Well, this would be 6 over 2 is 3 plus 2 is 5. So that's how you go from 6, 6 to 5, 6. Again, the y value is not changing here because we didn't do anything to it. I'm going to have that link for you if you want to play around with some more points. All right, what I want to do now is give you one example where we put everything together. So I want to just say that when you deal with horizontal transformations and vertical transformations, they do not impact each other. So you can play around with the order. You just need to make sure that you do things specifically in the order for the horizontal and for the vertical correctly. The way that you put them all together does not matter. So you might see different procedures out there that would still be correct. So combining graphing transformations, once again, I'm going to state that the order given below is for the factored form only. If your book tells you to do the horizontal shift first, that is because they did not factor. Okay, I can't stress that enough because a lot of people get confused in this section because there's different procedures out there and it's based on whether you factored or you didn't factor. So I'm going to put here first to factor out the coefficient of x. Then I'm going to say perform the vertical stretch or compression along with any reflection across the x-axis. Perform the horizontal stretch or compression along with any reflection across the y-axis. Perform the horizontal shift and then perform the vertical shift. So basically the way I like to do it is I like to just work left to right. This is very easy to remember and it will give you the correct ordering. Again, provided you have factored out the coefficient of x, you're good to go. And that way you can just say that I'm doing all the stretches or compressions with the reflections before any shifts. All right, let's take a look at f of x equals x squared. And then g of x equals negative 3 times the quantity 1/4 x minus 1 squared and then plus 9. Again, you might want to write this as g of x is equal to, this part right here is going to replace x right there. Okay, so this gets plugged in there. The negative 3 is on the outside. You could just write that. So negative 3 times f of, again, what am I plugging in for x here that would be squared? This right here. So this 1/4, might as well factor it now. So you'd have inside the parentheses x, and then how do I undo multiplication by a fourth? I would want to multiply by 4. So negative 1 times 4 is negative 4. We'll close all that down. And again, this gets plugged in for this. That's all we're doing. So you want f of 1/4 times the quantity x minus 4. Then you have this plus 9. So plus 9. Okay, once we have it in this form, you can scroll down. You don't need that anymore. And again, all I'm going to do is work left to right. You don't have to. There's different ways you could do it, but this is the way I'm going to do it. So I'll just say that this would be first, this would be second, this would be third, this would be fourth, and this would be fifth. That's all I'm going to do. So this on the outside, this negative right here, again, if I had negative 3 times f of x, that gives me a reflection across the x-axis, and I'm vertically stretching by a factor of 3. So I'm just going to say that we're going to reflect across the x-axis. Second thing is you have a vertical stretch, so that S is for stretch, by a factor of 3. Again, these can be done in any order. You can also put them together. Then when I get on the inside, you have to remember that you're undoing things. Okay, so you're undoing multiplication by a fourth. How do I undo multiplication by a fourth? I would multiply by 4. So that's giving me a horizontal stretch by a factor of 4. Horizontal stretch, again, this S is for stretch, by a factor of 4. Let me fix this A here. All right, then for the fourth thing, again, you're going to go on the inside of the parentheses here. You have this -4. How do I undo that? I want to add 4. That's going to shift me to the right by 4 units. So we want to shift right 4 units. The last thing here, you have this +9. Again, this is on the outside. This is very straightforward. That's just going to shift me up by 9 units. So let's say we're going to shift up 9 units. So if you take something on the graph of f of x equals x squared, so some x comma y, when you get to this g of x, which we've written as -3 times f of 1/4 times the quantity x minus 4, and then +9, this is going to end up being what? Well, for x, you have a horizontal stretch by a factor of 4, so I'm going to multiply whatever the x is by 4, and then I'm going to shift right by 4 units, so +4. Then for the y, these two would be done together, so I'm going to multiply by -3, so -3y, and then I'm going to shift up by 9, so +9. So that's all it is. So you can use this to check, and I have a little graph for you. Let's just do all the points here, and again, if you want to click on the link and do more, that's up to you. So you have something like -2, 4, that's on the graph of f of x equals x squared. Well, that's going to go to -4, -3. Again, just following this, you have 4 times -2 plus 4. Well, this becomes 4 times -2 is -8, plus 4, that's -4. That's how you get the x value of -4. For the y value, you have -3 times the y value of 4. Let me make this better here. And then +9. Well, -3 times 4, that's -12. And then +9, that's -3. That's how you get the -3 there. If you look at something like 0, 0, well, that's going to go to 4, 9. So basically for that, this is going to go away, and this is going to go away. You'd have 4, 9. That's very straightforward. Then this one right here, which is 1, 1, that's going to go to 8, 6. So let's go 4 times 1 plus 4. This is 4 plus 4, which equals 8. That's how you get the 8. Then for the 6, again, you'd have -3 times your 1 plus 9. Well, this becomes -3, right? -3 times 1 is -3, plus 9, that's +6. So that's how you're going to get that +6 right there. Again, if you want to play around with this on Desmos, I gave you the link. You can check all the points that you want.